Welcome to Polar Steam Cool Connections live stream. We're really excited to have you here. Will we wait just a minute for folks to join? Please go ahead and post where you're watching from, and if there's more than one person, how many people are there with you watching at your location? Welcome, everybody. All right, we're so glad to have you here for the Polar Steam Cool Connections. Please tell us where you're joining from and how many people are watching at your location. I'm Melissa Barker, and I'm the Outreach and Engagement Lead for the Polar Steam program, and we're excited to have you with us today. The Polar Steam program is a U.S. National Science Foundation funded program based out of Oregon State University that facilitates virtual and field-based collaborations between polar researchers, educators, and artists to enhance science communication and bring polar science to everybody. Recording of this live stream will be posted on our YouTube channel. And today we'll keep the focus of this event on the science and the experience on the ship. But in case you are curious, all of our applications are currently open. And so if you are an artist or a writer and interested in applying, that application closes soon, July 15th. Our educator application closes August 8th. And we are now recruiting NSF-funded polar researchers. We'd love to talk to you. And if you have questions about our artist, educator, or researcher programs, we encourage you to watch the videos that we have posted on the YouTube channel, and then also view the information on our website. Today, we are excited to connect with 3 of our Polar Steam Fellows who are aboard the research vessel Steadfast outside of Petersburg, Alaska, near the LeConte Glacier. We will start with a presentation from the fellows in the field and follow up with a question and answer session. We invite folks to submit questions in the live chat. Our team will monitor these questions and we'll address those questions and questions submitted ahead of time at the end of the presentation. This gives you a little sense of where we are today. And then now I want to introduce our fellows. Jesse Cusack is a physical oceanographer and polar researcher at Oregon State University. He is broadly interested in turbulent ocean currents and their role in Earth's climate. Recently, he has focused on currents occurring adjacent to marine terminating glaciers and their impact on ice melt. Vanessa Hawkins is a PhD student in physical oceanography, also at Oregon State University. She is currently studying the dynamics of freshwater plumes discharged by marine terminating glaciers, and she's interested in understanding how freshwater plumes affect glacier melting and the surrounding fjords. Brittney Stoneburg is the Collections and Communications Manager at Western Science Center and a vertebrate paleontologist. She is also passionate about science communication and outreach and is spending 2 weeks aboard the RV Steadfast with the team. Brittney, Jesse, and Vanessa, we are thrilled to have you here with us today. We know there's a lot going on in the ship, so we really appreciate you and the time that you're going to give for us today to learn a little bit about what you're doing. So on that note, I'm going to turn it over to you guys.
All right. Hi, everybody. So kind of made a few slides to show off Jesse and Vanessa's work and exactly what we're doing here. And so the first question that I think anybody might have about this kind of research is, where is it happening? So if we can go to the next slide, please. Perfect. So this is a drone shot we took of the RV Steadfast. So this is the ship we're aboard. We are currently watching on a watching on a very comfortable couch in the ship. And you can actually see to the right-hand side, that's one of the small boats that goes out to deploy monitoring instruments. So that's kind of the ship we're on right now. Next slide, please. And this is a shot of LeConte Glacier. So this is where Vanessa and Jesse are working. How many times have you guys worked out here?
This is my 3rd time.
This is my 2nd time.
Yeah. Next slide, please. So now that we know where it's happening, why it's happening. So why are Jesse and Vanessa and the whole team of researchers aboard the RV Steadfast here studying this glacier? Next slide, please. So this is actually a really cool picture that I want to give credit to Adam Lucas, who is a graduate student on this vessel right now. We worked together to make this image. The background image is LeConte Glacier from 2018. So the black line is a terminus line that was made in 2024, so just a year ago. And the red line is one we actually made a few days ago with our drone. So you can see the glacier advancing and retreating again. Next slide, please. Oh, and there's a video here too that I took with a drone. You can see on the left-hand side some of the ice crashing off of the glacier and into the sea. We're doing it again.
Kind of fun to watch.
It is
multiple times.
It's kind of mesmerizing. It's mesmerizing to watch in person.
Yeah, for sure.
That's a big piece of ice.
It's a very big piece of ice.
It really rocks the boat too.
Mm-hmm. And so these are some of the bullet points that I've made to kind of show like what Jesse and Vanessa are working on. So if either of you would like to expand on any of these, of like why LeConte Glacier is just so important and why you're trying to understand it.
Sure, I can start us off. We're trying to understand how the ocean melts glaciers, and it's not quite as simple as a like ice cube melting in your glass of water, because in that case the ice kind of cools down the water and it's cold and it tends to sink. In a glacier, because the ocean water is salty, when it melts, it produces fresh water and that melt water rises, and that changes things a lot. It creates these really energetic currents, and we think those currents are really important at making it melt even more. So we're trying to understand those currents, and those currents, they kind of erode away at it, like they're scraping away at the glacier, and at some point it can become scraped away so much that it becomes unstable and pieces of ice break off and it loses mass. And so yeah, we think these processes are really important. And LeConte in Alaska is a really great place because it's easy to get to. It's only 2 hours from Oregon, and there's a lot of resources nearby, ships we can use. And it's been studied for a very long time. So we have a great record of what's been happening here.
Cool. Vanessa?
I mean, I guess I could add, tying back to your image before of the terminus, there's kind of like a lot of different ways to see how the glacier is melting. Like, of course, you're seeing giant chunks of ice coming off and calving, and you're seeing over like several years the terminus is changing. Sometimes it's expanding further out into the fjord, sometimes it's retreating back. But also, like Jesse was saying, you can see signatures of melt because of fresh water that's traveling through the glacier and then coming out in the ocean by the glacier. So it's just like we're trying to understand a lot of these things at the same time and how they come together in this very complex system.
Awesome. Next slide, please. So now that we kind of know why you guys are working on this, the next question I had was how? How are you taking all the measurements you need? This isn't nearly all of the equipment that the team is using, but this is some of the equipment that the team has been using this week to take these measurements. So on the left-hand side is Dragon. And so if I remember Kaylin is one of the PhD students who on this. This is just a rigging for a lot of different sensors and monitors all at once that gets pitched off the side of a boat, correct?
Correct.
Cool. And then in the center is an EM apex float. And somebody remind me what an EM apex float measures.
They are just measuring water velocity. So they profile up and down in the water column. So they're moving around because they can change their buoyancy, and they're measuring velocity of the water around them.
And then on the right-hand side of this slide is the microfloat. So those are what Dr. Trevor Harrison at UW is University of Washington has been working on. And I asked him about it last night, and he said that the microfloats are sort of like the EM Apex, but they take a few different measurements, and they're also smaller, which can be very useful in different situations.
Yeah, absolutely. These are measuring conductivity, which we can use to find out how salty the water is, salinity. They're also measuring temperature and pressure. And what's cool about these floats is that they can go inside of that plume of subglacial discharge that Jesse mentioned earlier that's happening when the fresh water is melting from the glacier and coming out into the ocean. So these can get sucked into that plume and take measurements inside. And we, in our big research vessel, can't go right up to the terminus because of all of those chunks of ice falling off. So it's cool to have devices like these floats that we can deploy from our vessel at a safe distance away from the glacier terminus, and to be able to see these data we wouldn't otherwise be able to collect.
Yeah, next slide, please. Yeah, so this is kind of demonstrating how they get all of that equipment to the glacier, because we don't want to put actual humans that close. That little orange boat in the foreground is Polly. Polly is an autonomous vehicle that can be driven by Jasmine, who's one of the technicians here. And it's a fully autonomous vehicle that can be used to deploy those kinds of monitoring equipment that we just showed you. It's very cool to see it be driven.
And big moorings too. We have not, I don't know if you have any pictures of the moorings, but these are staying stationary underwater, and they're profiling from like very close to the glacier. And so we were using Polly to bring them right up near the terminus to take data.
Next slide, please. So this is some of the team. This is Katie, Jess, and Jonathan in Whaley, one of the small boats that is taken out to deploy equipment. It's very fun. I got to do that like 2 days ago. I got to go in Whaley. Whaley is very fun. It was great. Next slide, please. This is Ashley. Ashley is doing a CTD cast. So that was testing some equipment right off the side of the boat, dipping it in, and then pulling it right back out to see that it worked. And CTDs measure, let me see if I remember this, conductivity, temperature, and depth.
Yep.
Bingo. 3 for 3.
I remembered. Okay. So this is Ashley doing a CTD test on the first day. Next slide, please. And this is Rift Raft. This is one of the larger boats that they were taking out. And I think this day was it sonar, I believe? I remember.
We grabbed the VMP, and that measures how turbulent the water is.
Okay, that's what it was.
That's what the fishing reel on the back is for. We're not actually fishing. We're fishing for data.
Fishing for data. Yeah, so in addition to the RV Steadfast, which is our kind of big ship, there's a lot of smaller boats that are driven by humans and some that are just driven autonomously that can help get that equipment closer to the glacier. Because, yeah, when you see all the ice go and you see the calving events, it also emphasizes how dangerous it can be, I think, to get people that close to the glacier. So this really helps.
Yeah, for sure. The Whaley and the Riff Raft, which are the two boats that they kind of live on this larger vessel that we're on, and then we crane them off when we need them. Those can go up to like 300 meters away from the terminus, whereas the autonomous vessels can go all the way up. And then this larger vessel just can't move as fast, and so it can't be very close when we have calving events happen.
Which can happen a lot, like yesterday.
Yep.
And just now.
Oh, yeah.
Oh, really? Oh, we missed one. Maybe we can get one on live stream for everyone.
Yeah, we'll just move around the laptop. Next slide, please. Okay, so yeah, that's kind of our what we've been doing all this week on the RV Steadfast. So we're more than happy to answer any questions you guys have. Also, once we've got some questions, I think we can also try and maybe take the laptop out with us. And
yeah, we can do a little
pictures like right over there.
Awesome. Thank you guys so much. That was fantastic. Some of those images were incredible. The blueness and the colors of the glacier are so cool.
This was my first time. This trip has been my first time seeing a glacier in person, and I was not prepared or expecting how like blue the ice is, like how deep that blue can be. So yeah, it's definitely something that's hard to convey.
Nice. Oh, that is great. Let's see. Do you want to take us outside first and then answer questions, or we can answer
Let's take a
since you,
little. Let me
yeah,
take a
little
little
trip?
walk. See, I'll be right back.
Okay.
Let's see if we can do this without me. Let's see. I need to unplug my computer here real quick. You.
And Vanessa, we have word that your grandma is watching. So maybe you want to say hi. Oh.
Okay, let's see. Okay, I am not going to lose my laptop off the side.
If you need me to hold yours or anything.
Okay. Hi, everybody. All right. Whew, it is windy and it is rainy, but we're going to turn around and that's the glacier right over there.
You can probably also see riffraff.
And you can see riffraff. Yep. You can see riffraff going out to deploy equipment. Yay. Woo. There you go.
We could take them to the
Yeah, let's go this way. It is a little rainy out here.
Everything.
Da, da, da. So right here are those EMA PEX floats that I mentioned. And now they have, so part of what the EMA PEX floats is that you have to go get them. And they can be very hard to see when they're just floating in the water. So you have to sit out with binoculars trying to find them. So now they have little hats that'll make it a little easier for us to see them and recover them.
A little easier.
A little bit. It's still probably gonna, it's like we were saying that it was like advanced Where's Waldo trying to find them.
Oh, that's great.
Yeah.
Love it.
Oh, more glacier. So cool. Oh, and I think that's another little small boat down there.
That's
ready
Whaley.
to go. That's Whaley.
Yep.
Ready to go. Woo. All right. Very
There's
cool.
some microphones.
Oh,
Oh,
let's
yeah.
see. Oh yeah, they do have microfloats. Okay. And then right here. So these are the smaller microfloats that we were talking about. And I think hopefully you can see now that we've shown them on video how much smaller they are than the EMA PEX floats. Yeah.
So do those get loaded? How do those go out? Are they on the side of a boat?
We toss them aboard so we can take out the Whaley and then throw them over the side. Yep. And then they follow the currents in the fjord as they're out, because they're out for like 4 hours or so.
And then you just pick them up later?
Yep. Yep. Yeah, we have boat hooks, or we can take the Whaley and get those. I think we can either use the Steadfast, the larger vessel, or one of the smaller ones to grab them. Yeah. They haven't been out much yet. There's been a lot of testing, we put them on a little leash and put them out so that we make sure they're working before we send them out to take profiles near the glacier.
That makes sense.
Yeah.
That's a good idea.
Yeah.
Troubleshooting's important.
Mm-hmm. Yeah. So lots of testing, lots of troubleshooting. So
Yeah, I was going to say, it seems like with all the technology that you guys are using, how have you had, has it been pretty reliable in terms of what you've been able to, capturing the data, has it been pretty reliable, or have you had a lot of problems?
Sorry, is capturing the data reliable?
Yeah, like have you had to troubleshoot a lot, or has it been has it worked pretty well?
I mean, it's normal to have to troubleshoot a bunch of things. Oh, thank you. We've had some issues with satellite communications. You can see behind us, the mountains are pretty tall, and so a lot of these things, when they come back to the surface, they kind of call us over a satellite, and that's how we figure out where they are. But a lot of the time, they have been struggling to call us because the mountains have been blocking our signal. So that's been a challenge. But otherwise, we've had a lot of successes, like the team who've been out in the riffraff recently have been getting great data, and the some of the things we won't know until that's also part of this is we put stuff underwater for a whole week and then we only find out at the end whether it actually works. So
Yeah. Oh, that was
that was a big one. Hold on.
I don't know if you guys.
Let's see if we can.
calving
I'm not gonna drop the
chunk?
laptop. We're gonna see if we can see it. We heard a big crack.
Oh,
It's
wow.
like thunder.
Yeah, from where we are. Yeah. Whew.
And it makes a big wave.
Yeah.
Do you feel it in the boat from where you are?
Yep, everything
Mhm.
rocks around.
Yeah. But it's actually, it's not, by the time it gets to us, it's not a very big wave anymore. And it's, the ocean can be a lot rougher than this, so not too bad.
Gotcha.
Yeah, there's not really much getting seasick out here. Pretty calm since we're so close to the coast.
Okay. And I just want to remind folks who are with us on the live stream, if you have questions for the team, please post those in the chat. And we've got one for you right now.
Right.
And I don't know if you guys want to stay there or go inside. We can hear you fine, but that's up to you guys.
We're not. That's on you guys.
Your laptop's getting a little
Yeah,
wet.
my laptop's getting wet, so
Yeah.
let's go.
In the way.
Let's go
Okay.
inside. We're on a.
We'll let you guys head
Okay.
inside.
Yep.
Okay. Thank you. That was really cool.
Yeah. Yeah, it's really hard to describe the sound of the cracking. It's incredible. Okay, here we go. All right. Oh, adventure
And
laptop.
Yeah. And actually, as since we were just talking about the calving, is that something that's happening like all the time, or is it like certain times of day, like, or random?
It's kind of random, but I would say as it heats up more during the day, so it happens more often like afternoon, like around noon. So not so much in the morning, but it'll start happening again around like 10. But even last night, when we were going to bed, there was a lot of calving. You could tell the boat was rocking. But yeah, that happens. That's just an active sign that the glacier is melting, and there's lots of processes going on within the ice to cause that.
Okay. Wow. All right. So we have a question from Kai that is asking, what is the leading theory for how the freshwater is impacting ice melt?
Oh, yes, I don't know like a leading theory, but I would say one of the biggest dynamics at play is that subglacial discharge plume that we were talking about earlier, that the microfloats can go in and profile. And it's kind of interesting because the glacier's own meltwater is making it melt even faster. And since we haven't traditionally been able to get a lot of observations within the subglacial discharge plume because it's so close to the glacier, we don't exactly know how to parameterize it. We have theories and stuff, but the theories and the observations need to be aligned.
Yeah, I would add, I mean, part of the reason we're here is because the theories we have are, they're not necessarily working well to predict the melting, given how they were built. And one reason for that might be that the currents are stronger than we thought they were. So that's one reason for being out here, is to measure how strong those currents are. But we could be missing certain kinds of dynamics that are happening that we hadn't realized were happening. And so, that's kind of the whole reason we're here, is to figure out where the theories work and where they don't work and why.
Gotcha. Thank you. And I just want to give a shout out to the Western Science Center, all the folks watching there. Want to say hi, and we're so glad you're watching, all the staff, volunteers, and visitors from the Western Science Center. So thank you so much for joining us.
Hey, everybody.
We're so excited that you let us borrow Brittney for a little while.
Thank you. I appreciate it, boss.
Awesome. Well, while we still have everybody there, because I know there's a lot going on in the ship right now, I wanted to ask for Vanessa and for Jessie, what inspired each of you to get involved in polar science or oceanography? And what advice might you have for students that are interested in pursuing a career in oceanography or polar science?
Sure, I can start on that. What inspired me? Well, I like the I like remote places. I like going to cool places. That might have been the initial inspiration, for sure. But it's actually it's a really challenging place to do work, and because of that, you have to be really creative. You know, you have to come up with new technologies like all these floats and things that we're bringing here. And that's just a really fun thing to do. I'd say it's maybe the main reason. It's really fun to work out here. You have to think hard about problems, and it's often a struggle, but that's it's part of the adventure.
Definitely.
Do you not have advice for anybody?
Oh yeah, any advice? Sorry, they're a two-part question, right?
Yeah. Advice for people, for students getting into this. I would say think hard about what aspects of polar science interest you. Because if you're interested in this kind of stuff, there's with what we do. We come at it from a physics and a maths background, and a lot of us are engineers, things like that. And so if you're wondering, and a lot of us we didn't start off thinking we were going to be polar scientists to begin with, right? We came in from physics or mathematics, some other field. So just think about what interests you, because there's many different ways to get in. There are people who study the biology. There are people who study they do the geology. There's all sorts of things going on, and so just do some research into what, and figure out what kind of thing you're interested in, because there's just so many ways to be involved.
Nice. Thanks, Jesse.
Okay, I think my answers are a little bit different because I'm a first-year PhD student. So, so I just got done with my undergraduate degrees in physics and music. And the thing that drew me to oceanography, I think, was because I wanted a hands-on way to do physics. I had a couple different research experiences, and when I was an undergrad, and there were things I liked, things I didn't like. But what I learned from that overall is I really wanted to be able to apply physics to problems in the environment. And oceanography was kind of just a natural way to do that. I think polar science specifically was a kind of random that I got into that, because it was just like when you're applying to grad school in OSU, it's kind of dependent on like what professors have available funding and available projects. And it turned out to be a good fit with me and Jesse. And I ended up really loving working out here. So it worked out really well, and I'm glad that I'm doing polar science. I would say my advice is to maybe undergraduate students thinking about grad school, thinking about getting involved in oceanography, is just to not be afraid to try new things and to branch out, to try different research experiences to figure out what you like and what you don't like. Because I went from like soft matter physics, studying plastics in a lab, to studying the ocean. So yeah.
Awesome. Thank you. Okay, another question kind of about some of the technology that you guys are designing. So what is the biggest challenge when designing technology for glacial research? Like extreme cold, salt water, or is there something else entirely? And how do you fortify or adapt the equipment to survive and function in such harsh conditions?
Sorry, what was the first part of the question?
Yeah, the first part was, what's the biggest challenge when designing technology for use in the area where you are? So is it extreme cold, salt water, or is there something else?
Yeah, I would say salt water is always a problem in oceanography, and yeah, it's highly corrosive. Electronics hate salt water, so that's a big deal. Another issue is the pressure. So we're actually in about 600 feet of water here, and some of the sensors we're putting down are going all the way to the bottom, and they will, if you don't build them right, they'll get crushed and they'll leak. So you have to make them really robust. And then they also have to be robust enough to kind of survive being knocked around by ice. So yeah, those are a couple of the challenges. But we've gotten pretty good over the years of making things that don't leak. Touch wood.
Nice. That's great. That's great. Anything to add there, Vanessa?
Maybe just like for deploying instruments, a lot of it depends on the ice conditions at the glacier, and that varies from day to day. And so sometimes even if we have the instrumentation maybe working like we want to, it's not going to get deployed when we want it to, just because of,
huh?
yeah, exactly. There was a mooring we wanted to get out a couple days ago, and there was just, because of ice conditions, we weren't able to. Things were just choked up, and yeah. So that's something also to consider.
Gotcha. So okay, so in your research, and I'm trying to ask the more research focused ones because I know that Jesse may have to go in a bit. So what do you oh, actually, first, have you, so I think it's Vanessa, you said you worked there 2 years, and Jesse, you've worked 3 years. Has it been three in a row, or is it over spaced out?
Let's see. I think I first came here in 2022, so that was. Is that right? I think so.
Time.
Oh, I don't know how long ago that was.
Okay.
Seems like a long time ago.
So I guess we're wondering, like how much change you've seen in the time that you've been there. Whether it's through your data or through visual, visual or data or both.
Oh yeah. I mean, some things stay the same, and some things change very obviously. And where the ice is and its shape, that changes really dramatically from year to year. And we also have some sensors that can see how deep it is. They can they can map the seafloor, and that is changing also very rapidly. You get little, they called moraines. They're these hills of sediment building up. The glacier is churning out dirt essentially, and so the seafloor is changing really rapidly, and we can map that. And so is the ice. I mean, the image that Brittney showed at the beginning, where the terminus was there, and then next year it was here, and then the other year it was there. So yeah, we noticed those things. It's really obvious, but other things they don't change. Like we come out here, there's always loads of seals, and it's always raining. So, in some sense, it stays the same.
Okay, so yeah, Vanessa, anything to add there?
My first year coming out here was last year. I guess we were on a different vessel, so there's some things like that have changed. We have a bigger lab space now, which is nice. But aside from that, I'm really excited to see the microfloat data, to see if there's any significant changes in the subglacial discharge plume, and to see if we can observe it further down in the water column.
Awesome. So okay, was curious about the picture that we saw with the dates and so it was actually, maybe you can talk a little bit more. In my mind, I'm thinking the glacier is just retreating, but it seems like it's actually, tell us a little bit more about what's happening year to year, seasonal.
Yeah, so it's very well. So this is straying a little bit from my area of expertise. So I'm an oceanographer, and the glaciologist would have a much better understanding of exactly what's happening here. But glaciers can go through retreat and advance cycles, and it depends. Sometimes the buildup of these piles of dirt, they can be an important part, because if you imagine building up a big pile of dirt, that actually blocks ocean water from reaching the glacier, which might prevent it from melting. And then if something, say it melts a little bit, or icebergs carve off and it moves away from that pile, then all of a sudden warm water can get there, and it can suddenly start melting a lot more. So it can be quite a variable system, and there can be cycles in these changes. But generally around the world, glaciers are retreating, and they're retreating by a vast amount. These kind of things, cycles are happening over years and decades. But if you go back many decades, right, the glacier used to be several miles down the fjord from where it is right now. And in fact, I think in the beginning of the early 2000s, it suddenly retreated by several kilometers, and it's kind of reached a point now where it's been a little bit more stable for several years. But yeah, it's a mixture of things going on.
And would you say that the LeConte Glacier is like pretty similar to other marine terminus glaciers like in Alaska, or are they all just really variable?
Let's see. So there are many marine terminating glaciers in Alaska, and many of them have similar characteristics to LeConte, where there's a couple of 100 feet deep, the ocean, and they tend to be flowing quite fast. The ice is moving at 10 meters a quickly. It moves pretty fast. And you can't see it, but it's moving, and so there are a number of glaciers in Alaska with similar properties. And in fact, that's one of the reasons we come here, is because it's kind of a good analog for other places. But including some in Greenland. But if you go to Greenland or Antarctica or places like that, you'll find much bigger glaciers than this. Like, this is quite a small glacier compared to some of those.
And you said you cut out there when you said 10 meters per
day.
Per day. Okay.
Which
Awesome.
seems really slow, but for a glacier, that's ripping along.
Yeah, that seems fast to me. Nice. We have a couple questions from the Western Science Center. One is, how cold is it up there?
It varies. I can't actually look at my weather app because I don't have signal. So how cold has it been?
I don't know, like 30s, 40s.
Yeah.
Depends on if it's raining or not.
Yes, if it's raining, it feels a lot colder. If it's windy, or if you're out in one of the small boats near the ice. But yesterday kind of felt balmy. We were so excited yesterday because the sun came out. We all went out on deck and we're like, there it is. The sky's blue again.
And if you're getting closer to the glacier, I'm assuming it feels like much colder. The coolness coming off of the glacier. That's really cool.
So for everyone back at home at the Western Science Center, it's much colder here than it is back at home right now.
Mm-hmm.
I'm assuming it's been over 100 degrees back at home. So this is great.
I have 4 layers on.
Nice. And then are you doing any long-term monitoring where you're leaving devices to continue to collect data and then pick them up like the next year? Are you doing anything like that?
We are not. Some of our colleagues who are on the ship even have been doing that in the past. I know of a project that involves high school students, I think, from the local school come out here, and they measure where the glacier is every year, I believe. And there have been kind of occasional projects. There's a big project start in 2015 to 18, and then earlier than that, there was a bunch of other stuff. So we kind of have this slightly sporadic record with occasionally really, really good data times and sometimes not so good. But we're not doing anything like that. This is the last field season for our project, so we're not going back.
Okay. Thank you. Let's see. What are the most, or how about for Brittney, what aspect of the experience has surprised you or been the most unexpected so far?
Ooh. Like I said, this was kind of my first time in an environment like this. Was also kind of my motivation. I was wanting to go to a more polar environment. And so experiencing the glacier, like I have a little bit of a geology background, having worked at the museum. And so you read about what glaciers have done to the landscape in the past. So the way I've always read about glaciers is something very like something that happened in the past and that carved out parts of the landscape. It's very different to see an active glacier right now. That's an experience that I was kind of surprised by. Like I said, I wasn't prepared for like how active it is, how loud it is when it calves, how blue it is. It's just a very different experience. And as, like I said, as someone with a geology background, it's really cool to see like when you see the glacier, you kind of understand how it can like carve out the landscape and how that's possible. So it's really kind of given me a different understanding of some of the things that I learned in like, Geo 101.
Nice.
And also just ship-based life is something that I've been learning a lot about. It's a very different rhythm to field work. There will be like periods of downtime and then periods of like an absolute flurry of activity because suddenly there was a window to like go collect data. So that's been really fun. That's an entirely new experience for me. And so learning about, how you conduct scientific research on a ship has also been really cool to learn.
Oh, that's great. And so it sounds like, Brittney, you've been going out in some of the small boats, you've been helping. What else have you been doing on the ship? Uh-oh, I think we're frozen
I think
for
we're
a sec.
good. Can you hear me
Okay.
okay?
Yes,
Awesome.
I can hear you.
Yeah, so I've kind of been like helping out wherever they need an extra pair of hands. I've been asking lots of questions, and everybody's been very gracious about that, about me asking so many questions about what they're doing. What I've been doing a little bit is actually helping out with some of the flying drones. So me and Adam, grad student, who helped, who put together the image that we used in the slides, have been using drones to, one, take cool pictures and video, but also to measure the terminus of the glacier. So we'll fly the drone over every morning and take pictures of the entire line of the terminus of the glacier and just kind of compare it each day and see what it's doing, which is very cool because sometimes you can do that and you can see like a very obviously large calving event happened and there's a chunk of ice missing. So that's been really cool it's a very fun environment to fly a drone in. It's a little nerve-wracking. You have to land it on a ship, which is a new experience for me, but it's been really fun. But yeah, just been here taking lots of pictures and video and asking lots of questions.
Oh, that's great. And how great that you already knew how to fly drones, so that was pretty helpful. Let's see, I think we're getting close to our time here. But I want to just see if there was anything really surprising that you're finding so far. I mean, I think one thing Vanessa said earlier was like that was surprising to me was like the meltwater was like it's like a positive feedback, right? It's like melting, the meltwater itself is making glacier melt more. But is there, yeah, any other surprising findings that you're seeing?
Yeah, I think it's still a bit early in the campaign. Like, for example, we haven't been able to get the microfloats out until today, and those are the instruments kind of that will be in the subglacial discharge plume. But I've been involved in profiling on the riffraff, so that's using that electric fishing reel to drop an instrument into the water. And so I've been looking at some of the CTD, so conductivity, temperature, and depth data from those transects that we took across the fjord. And I would say maybe nothing surprising so far, which, I've seen things that I expected, but there's so much more time left in the campaign to see new things.
Which is not a bad thing.
No.
Yeah.
Yeah, I think
There's some parts of the system that we understand pretty well, and we keep measuring them again and again, and that's an important thing to do. But yeah, like Vanessa said, there's a lot of the data. There's new instruments that we put out on moorings, which we're not going to get back until the end. There's the floats, which are going to do their thing today. So yeah, we have a lot to find out still.
nice. That's great. So, can we, how might we follow along on social media if we're interested in seeing what you're up to out there, Brittney?
Yeah, so I've been sharing on Instagram and tagging Polar Steam. So that will be shared there. I'm going to be sharing through my museum as well. So you can follow at Western Science Center, and we'll be sharing some stuff through there as well. And then when I come back, there's going to be all sorts of photos and videos, and I'll be sure to share those as well.
Excellent, excellent. All right. Well, is there anything else that any of you want to share that we haven't asked about the research or about the experience that you're having out there?
I'd like to thank Polar Steam for the wonderful opportunity to have Brittney
Yeah,
here.
oh,
She's been lovely.
Thank you. No, this has been great. We'll say maybe life-changing. I don't know. I grew up in I grew up in a desert, and so I have always had a fascination with polar regions, mostly because I like the cold and it's very hot where I live, but also because I think it's these areas that people think of as desolate sometimes, and there's actually a lot going on. There's a lot going on in these environments, and they have a lot to teach us. So I'm very excited. I'm just very excited to be up here, and I really appreciate Jesse and Vanessa taking the time to field all of my questions, because I don't have a physics background, so I've been asking a lot of them. And it's been very cool, and I feel very privileged to see them do their research. And I think it's actually really important for that research to be disseminated to the public so that people can learn more about this glacier and the people who are studying it.
Yeah,
Definitely. Yeah.
I would just add, yeah, Brittney's doing great at flying the drone. It's really helpful. I would just like to say that, you see us three primarily, but there's a whole team of us here, and it really takes a large number of people from faculty at the university to technical staff to graduate students to all the support staff in NSF and team, and it's just when you add it all up, it's dozens and dozens of people to make something like this happen. And so we couldn't be here without this huge team of great people.
And shout out to the crew of the Steadfast.
Exactly.
They're amazing.
Nothing would happen without
Yep, somebody needs to drive the boat, and man, the food has been amazing.
Oh, that's great. That's great. All right, so I'm going to share one last slide here and kind of wrap it up. First of all, again, thank you, Jesse, Vanessa, and Brittney, for your time. We know that time is so precious out there in the field, and we hope that your fieldwork continues to go well. To all of our viewers, thank you so much for joining and asking great questions. There are many ways you can see here to engage with Polar Steam. You can subscribe to this YouTube channel. We have for future live streams and other videos. Follow us on social media at Polar Steam Team. You can see our blog and our educational resources and program information on our website. A reminder that this recording will be, or this live stream will be recorded and posted on our YouTube channel. And thank you so much for tuning in today to Polar Steam's Cool Connections. Thanks so much, everybody. Bye-bye.
Thanks, everybody.
Bye, thank you.